Hi, and welcome to this clip going through a three-step organic synthesis level response question. So looking at the diagram, we've got three stages, and we've been asked how we could synthesize cyclohexene from cyclohexane using this particular synthetic pathway. Now along the way we have to give the identity of compound A, and we have to give the reagents and conditions for each of stages 1, 2 and 3. And finally we need to say what factors might affect the percentage yield in each case. Now I also suggest thinking about how to structure your answer before you start writing it out, so maybe giving yourself sections to write about rather than trying to juggle it all in your head at once. So let's start with stage 1. We have cyclohexane, which is an alkane being reacted with chlorine. Now the only way in which alkanes and chlorine react is via radical substitution. And when you get radical substitution of cyclohexane using chlorine, you're going to get chlorocyclohexane. Now because this particular mechanism isn't very easy to control, and there's 6 different places where chlorine could substitute, you could get multiple substitutions as well. It's not to say you'll get one chlorine substituting for one hydrogen. So it's worth bearing that in mind for the later on in the answer. So to achieve that, you need UV light. Now like we said a moment ago, you could possibly get multiple substitutions. If you get multiple substitutions, then you're not going to get the compound that's in the product of stage 2. And that means you might get multiple alcohol groups instead. So you could get cyclohexane 1,2-diol, or cyclohexane 1,4-diol, or 1,2,3-triol, for example. So bearing in mind that the structure you're given only has one alcohol group, you have to be careful not to assume that you're automatically going to get a single chlorine that's substituted in stage 1. So just to tidy the answer up a bit as I go, I'm saying that UV light is the reagent and condition for stage 1. So I'm now going to move on to stage 2. So you need sodium hydroxide or another source of hydroxide. Sodium hydroxide solution is the most common one we use, and you warm it a little bit because in the mechanism a few bonds need to be broken. So therefore to break the bonds, because that's endothermic, you need a bit of heat to get that started. And if you don't heat it enough, you might not get a very good yield, so we need to bear that in mind as well. So going on to stage 3, we are changing an alcohol into an alkene. So this time we're refluxing with concentrated phosphoric or concentrated sulfuric acid, because you're dehydrating the alcohol. And here maybe if the reaction doesn't go to completion, because obviously if you're refluxing you're having to inject quite a lot of energy to make the reaction work. So if the reaction doesn't go to completion due to insufficient refluxing or heating, that could cause a drop in the percentage yield. Okay, so that takes us to the end of this clip. That's one possible way of doing the answer, doing it in sort of chunks and stages rather than trying to juggle it all at once like we mentioned at the beginning. So hopefully this has been a useful clip to listen to, and once again thanks for listening, and until next time, see you soon.